Okay, I think I managed. Sorry for the delay. The stream was actually scheduled like half an hour ago, and it took me basically like better part of 50 minutes now to bring everything up and running. I hope I didn't forget anything, no? And I hope it keeps working, and we don't have any crashes like last stream. So my stream setup mojo is very low at the moment. But yeah, never mind. Yeah, so basically today we'll just continue basically where we left off last week. The only thing I did between streams was to fix the fan. We now have a working fan. I don't know what the problem was in the end. I basically just replaced the fan. I think the problem was like comparing this is the old fan. And what we discovered like last stream was that like, I'm not sure if you see it now, but this isn't like spinning like it's like wobbling a bit. Hi there, Harlem. Hi there, Steve. But basically like I just discovered like it wobbles a bit. Like when you spin it and you look at it at the right angle, like you see it wobbling back and forth. So I think like this wobble just causes the blades to touch the housing. I just replaced the entire fan with a different fan, and now it works as expected. So yeah, definitely the fan. Bit of a shame because, I mean, you never know if it's like original, but that is supposed to be a Sunon fan, so like more like a high quality product. And the new one I now have in there is definitely weaker and not much quieter. So I think this fan used to be better, but hey, if it doesn't work, it doesn't work. Yeah, so basically we have it up and running. And today we are gonna do a couple of things. And as I said, like, I hope I didn't forget anything. I completely forgot to put my project box next to me, so I missed most of the parts. I'll have to quickly fetch that in a second, but I got some new toys. So firstly, this arrived, which is a USB hub for the Raspberry. It's sized for Raspberry Zero, but also works perfectly well with the Raspberry Pi 4. Gives us a couple more USB ports. Why do we need that? So we need this because at the moment we have a ADXL 345 sensor in the toolhead, but not on the bed. So the bed is not able to like do the resonance testing without like external sensor. And it's kind of like annoying a bit. So I got this little guy here. This is a big TreeTech ADXL USB board S2W 1.0. And yeah, this will basically be mounted below the bed, like not here, but like somewhere there. We need to figure out the spot. And I have this is my last USB-C cable. I'm running out of cables. So basically we will run this cable along the drag chain under the bed. And then basically we just configure the second ADXL sensor. So that's something we need to do. And then the last thing we need to do for like hardware upgrades, we still need to replace the motors here. After that's done, hardware-wise, it's completely ready, and then we can just start our tuning endeavor. So basically, we have to like not tuning necessarily, but we need to properly configure the extruder. Yeah, and then it's tuning. So let me just quickly grab the box that I have all the parts I need. And then I think like the first step would be, it's most likely easiest if we just remove the bed for now, that we can like properly work on the undercarriage. And we have to run the cable. So yay, more cable running. And the motor should be relatively quick. So let me quickly grab the thing and then I'm right back. Okay. We have motors. And I also figured we need some VHP tape, so I also got that. Cool. Let's get started. So, I didn't take this bed off for a really long time. Oh, and I remember that we did something to the nut so that they don't come loose. I can see another update to his cable extension from the bed where I also fitted the ADXL. I'm not quite sure if I understand, Steve. Let's see. Maybe we can do this by just putting it on the side. Just like the tricky part will be like to work on the cable chain. Because I know that like those are like quite level, and I think I used, I'm not quite sure if I used thread locker or a bit of glue to like put the nuts in place so that they don't self adjust. So let's see, maybe we can also just, we need to remove the motor here anyway, right? So if we need to remove the motor, because technically like we have enough space here to stick that, so it's mostly the cable chain. Let's see, let's try to leave the bed on. So basically I think we have to remove the motor mount here. And I guess we should also release this screw here. There's a tensioner. Oh, there's another screw here. Totally forgot. So basically these are not the standard, these are not the standard motor mounts for the switch wire or for the Enderwire. This is like a modified version that has an extra screw here. I did that, or I added this. This is quite hard. I should have used thread lock or something here. I added this one, or used this like modified version, because basically what happened, I used thread locker, I see, is that the motor mounts always start to tilt a bit from the force of the belts, doing this tilting motion. So I think this is a really good upgrade actually. I don't fully understand why. It seems like this is stuck somewhere. Like, don't see. Ah, yeah. Okay, there we go. So I tried to not make a complete mess with the belts. Yeah, but basically there's this like extra screw hole here on the back that just holds it against the extrusion. Oh, and I also remember now, here we had a bit of a funky setup. So basically we have this like plastic nut here and a proper nut here, because two of those metal nuts don't fit here, like the screw is too close. On the wire extension for the bed is space to fit the ADXL. I don't think that we fit it directly here. I figured the easiest is to just use VHP and stick it to the underside of the bed carriage here. So not the hot bed itself, but like there's this like aluminum plate below here. So I'll just stick it here and then like route the cable back and through the chain. I think that's the easiest. I mean, technically we can also like squeeze it somewhere in there. I think it's, yeah, let's take off the bed. Let's take off the bed. It's a bit of a pain, and I kind of don't want to re-level that, but let's take it off. I think we'll make it much easier to work. Okay, that's one screw. I need a proper driver for this. I don't remember what I used to fixate those nuts. I just remember I used something and my intention was for it to not come loose. Which, to be honest, I kind of succeeded. This is quite a thing. Wonder. Let's quickly check the other ones. If they are all this hard, then maybe I change my mind again. Also make sure to kind of collect the screws we unscrew. Let's quickly just flip this over. Also quickly unplug the motors. So that like when we move the toolhead, I already destroyed some stepper drivers by like moving the toolhead. So let's just be smart about that. Okay, this one is easy. And this one is easy. So we only have to wrestle one screw. Okay. It's still kind of like, one thing I kind of want to upgrade on this printer, and it's kind of like pointless to be honest, but I'm so unhappy with the ender bed. Like I feel like it's just not properly level. Or like not, level is the wrong word, it's just like not flat. So that's kind of like one gripe I still have, but it's really hard to change this bed for something else. Like something else higher quality, I should say. Like you can of course like flip, like put some other bed on here, but yeah. I mean, if it's not better quality, kind of pointless. And the other, or like the only option for like a really high quality bed in the size would be the Mark III bed, which also is used by the, or like the Prusa bed, which is also used by the original switchwire, but this is just ever so slightly too wide to fit. So this is, I don't know what I used there. Let's see, so there's technically enough space. Let me not use the pliers. Okay, I'll quickly need to grab some tools. Give me a second, sorry. Okay, let's try. Don't know how this is called in English. If this is already the correct size. Oh yeah, that's the correct size. So there's this thing in the kit, which might be just too long. Hey, missing like 3 millimeters or something. Shit. Let's see. I mean, I don't want to pull off the rail. That's one thing I don't want to do. We cannot take off the back. It's just annoying. Like I don't have like the how it's called, like the tool to like loosen that. I don't know what it's called, like the flat one. I don't have that for some reason. That's like, I don't know why I never bought those, but I don't have it. Let's try maybe like a different pair of pliers. Maybe I have more luck with that. Yeah. Oop, yeah. Okay, different pair of pliers did the trick. God, I think I used glue. Okay. This is loose. Then let me very carefully flip this over. After getting rid of this toolbox. Woo. That was unexpected. Yep, there's the fourth spring. Then, now the easy part. Collect all the hardware. So those of you who watched the original build series of this know that down here there are just a couple of Wago terminals or blocks. And while they're a little bit of pain to access, we only open the ones we need. They basically allow us to just like unplug the bed basically. And then there's this JST next to it. A little bit difficult to grab, but that through. So basically we can just like remove the entire bed in one go. If I get that JST. Here we go. Okay. Wonderful. Whew, that took a bit of convincing. But yeah, now we can work. Right? Now we can work. So use this opportunity to like dedust. We have the drag chain here, and we need to route the USB cable through the drag chain. I think that's kind of a good step one. I mean, space, like, I don't think it really matters where we place this. So we can just have the boards. I mean, even here would work, right? Like, there's enough space. Just put this here. The aluminum should like protect it from the heat of the bed, so it should be also fine. Yeah, so let's just try to do this. We just have to like kind of like see how we can easily work on this drag chain, because just like still like even with the bed remove, bit of a pain. How did we get this in there initially? And we can try to unclip the chain. We can try to unclip the chain on this side here. We have it all the way here, like we can try to unclip this. Then at least, basically we just need to access the chain links. Which I actually wonder whether we can, because like here those we can just open, right? Like these are should be relatively easy. Yeah, so these we can just open. Like all the way here, like unclipping here shouldn't be a big deal. Shouldn't be. Oh, it's not cooperating. Here, almost said it. Okay, maybe it's easier to snip the cable tie there and then just to unscrew it. On this side, we can also unscrew it like down here you see like the screws, so we can also unscrew it here. No, we don't have to unplug it. I think let's do that. Let me just quickly try again from this angle. So I only need to unclip this. I'm not quite sure why this is such a... Here we go. That was harder than it needed to be. So yeah, but on this side we definitely have to loosen the screws because there's no way I can put this there. Yeah, but basically we just have to access the last cable link here to open that. And on this side, to be honest, because yeah, okay, that's it. That should be it. Now we can open them all up. I expected this to be a bit painful, but I did not expect this to be this painful. The worst part is I thought about replacing this USB cable later on because it's not quite the cable I want to have in there. But after this tremendous amount of fun, I think this will stay there. Okay, let's see. So there's now like one link left. So the question is, if we can manage to push the plug through here, we can... No, we can't. Okay, this does not fit. So we also have to unclip this. I'm not sure if I make this like horribly complicated right now or if it's just really a bit painful. Here we go. Ugh. Whew. Okay. Then, worst part's over, I think. Now we can... Just a bit of shame, like if the cable would be black, I would be happy, but it's a white cable, which annoys me a bit. But basically, we just need it to be here. And we actually already can put it back. Like, it was just about opening that link. So you can already try. Yeah, that's back in place. And then let's just put this through here and just close one link for now. Okay, we also have to redo the cable tie here because this USB cable needs to go through the cable tie again. Like on the cable chains, you always have to anchor the cables on both sides. The cable must not move, basically. Then let's say, I'll say like, let's place this. So, weapon of choice is VHB tape. I would just go like a bit over the top here and just use like 2 strips. So basically just let them overlap on both sides a bit. My goal being this just being like super fixed in place. And we can actually just trim it. We can attempt to trim it. Okay. And now the fun part, removing the backing from VHB tape. Like, I really like VHB tape. Like, it just really keeps things stuck to where you want them to stay stuck. But like, the backing is a bit of a pain. Okay, that's one. I think I'm like out of form when it comes to like peeling VHB tape. I feel like this is almost off. It's just okay. There we go. Usually, like the tweezers are not super helpful with VHB tape. The knife is, from my experience, the best way to do this. Okay. Let's just plug this in so we don't lose it. I still want to like position it relatively quite inward, so that we have like not too much like overhang here with the plug. Something like this. I think I can even like, I feel it now with my finger on the back. Oh yeah, it's too late. I don't think this is okay, let's put it like this. Okay, so now it's like really, even put it a bit deeper, so I'm just like aligning it basically with the back side down here. Okay, let's quickly remove the plug. I'm just trying to like push it down a bit with my fingertips. I can barely reach it. I don't want to push on the board, obviously. I don't have any. Oh yeah, I have something. It's like just like a printed spatcher. Just gently push down a bit. Yeah, okay. That should be it. Then we can connect it. Yeah, now like the plug doesn't like stand out a lot here. And then let's do the last operation for like super tight spaces, which is this cable tie. So basically we have to somehow manage to convince a new cable tie to go through this thing here. Drop from this side. And let me use tweezers to kind of like push. Yeah. Yep, that was it. Here we are. I feel like if you work on printers like this, like you really have to be very patient with like very, very annoying tasks. Okay, perfect. Oh yeah, this was like not well designed. There's like this like cable loop here, but you cannot add cables in. Like you have to push them through. So this USB cable has no chance of going through there. Looking at this, I'm really annoyed that the cable is white. I'm not gonna lie. Okay, so this is now well secured here. That's okay. I shouldn't have cut it yet. It's a bit too loose. Let's quickly try it. I really want this to be done properly here. Because if the cables move, the cables will break. And one of the cables I don't want to break is the like the not AC, but the DC wires for the bed. Okay, let's really make sure to as well. Yeah, no, it's better. Let's see if I can get like another tooth. I think this is as tight as it will be. Perfect. And now the easy part. I'm just closing like every other. Oh, ah, shit! I put it on the wrong way. Well, luckily that's easy to fix. Let's try this direction. But wait. Oh yeah, wait, I just put it this way, wrong way. Here we go. Here we go. Park this here. Now look both in the right direction. Just trying to close every other here, just to keep the cables kind of inside. Okay, now the fun part, we have to close the last one. To be honest, we lost like one of those like closing lid thingies there, and I think I'm just gonna move the last one over where the one is missing. Wait, how did it open again? Let's move this one over, and we can just close this here, and then I can reconnect it here at the end, which most likely will be equally painful to get on than it was to get it off. Okay. The final fight. Yeah, almost. Yeah, here we go. Woo! It's on. I'm already annoyed by the white cable. Not gonna lie. Ah, okay. It is what it is. But it's working well, so mission accomplished. I would say let's work on the motor. Like, as we already have it on. Yeah, I definitely put like a thread locker in here. I think we should just add some back, I guess. I'm quite sure why I did that, but I most likely had my reasons. So this is a new motor, and that's the old motor. They're like the same size. But the new motor should be a lot stronger. Let's just transfer that in one piece. Let's make sure that the plugs face the same direction. Like, okay. We also have to move the pulley. Let me quickly like clean up a couple of things here. There's like way too much mess. And hopefully I find the Allen key I need. What should this? This one might also work. No, this is too small. I'm not sure if I used this Allen key today already. That's a bummer. Okay. Then no Allen key. Let's use a bit. I'm not quite sure if he had a jig to position those, but just looking at the shaft length, like it's like all the way at the top. So let's just copy the position. There's most likely a bit of thread locker inside, so I think the screws are loose, but it's not yet coming out. And technically we can also use a fresh pulley. I'm inclined to just use a new pulley. Let's try a bit of IPA. See if that helps. Let's give this like 10 seconds, and otherwise I'll just grab a fresh pulley and then I'll deal with that later. Luckily I have quite a bit of those. Okay, I think it's a later problem. Let me quickly grab pulleys, 1 second. Lot of fresh pulleys. Okay, then let's just add thread locker, and then the shaft length is identical between the two, so we can just basically copy visually the position, and should be fine. And maybe let me make sure to not use so much thread locker that I'm locking the entire pulley. Okay, let's drop this on here. That should be pretty much exactly the same position. Oh yeah, I see the thread locker like being squeezed out here. So our new motor. There we. You see, just no, that's still very much glued on. Okay, I'll figure something out. Can get this aligned. Like, I just used screws I had available, because those screws were not part of the kit I had. Let's just say like this screw head type is not the most ideal. Okay, this should be it. And then you have this M5 here, so let's use tiny bit of thread lock. Yeah, this is not supposed to be like tight, it's just to like prevent it from rotating. I think it's also why I use thread lock here, because like really the screw is quite loose. So this should still be able to like move. It's really just like to restrict the movement to up and down. Okay, then let's see if we get our belt back into place. Would have been smart to do this before we attach the motor, to be honest, but we manage. So just unhook it on top. I think okay, here we go. Not the most elegant way to do this, but it's on. And then like later, we can basically tighten the screw here, and this will pull the motor down and tension the belt. So later we need to just check the tension again. Cool. This is one motor. And I think the plug, yeah. So we need to check, because technically like the plug on the motor could be different between the two. I think it's the same. We just need to see, potentially we need to change the direction of the motor. Like it could now spin just in the opposite direction. But that's our first motor. Let's do the other side. Yeah, it's also really hard. Yeah. What I didn't do now, I kind of wanted to do like resonance testing before I take or like replace the motors. Just to see like how the resonance changed with the new motors and everything. But I did not do that now, unfortunately. I don't have my calipers. I'm really well prepared today. Oh, that's funny. The motors like each other. This goes in this direction. Let's first do the pulley, actually. It's a bit easier if it's without the cage around it. Okay. Let's just get a rough indication here. So that's 10 millimeters. Let's just move this 10 millimeters up. Make sure that we have one screw on the flat side of the shaft. I'm just pushing the ruler against the y-axis or the y-beam. Basically, I could just like push the motor against it and then like align the pulley. So this should be pretty much in the same spot. Double check. This is like 10. That's also 10. So that's good. Cool. And then, yeah, this pulley I'll pull off later. Let's not worry about that. Let's be a bit smarter on this side and do the belt first. It's a bit annoying to like hit those nuts. Here you go. Okay, so both are in. Let's also add a bit of thread locker here, and then we're done with thread locker for today, I hope. Too tight. Okay, and then we again can tighten this screw to tension. We just have to figure out the tension in a second. Perfect. Done. No more thread locker. Cool. Yeah, it's a bit wobbly on this side. Like, let's just give it like I mean, it doesn't really matter. It's just like about the tension. Like this can, on the normal switch wire without the screw, like it's way more loose in a certain sense. I think that's fine. One more to go, but this one should be quite easy. Let's just loosen the tension here right away. Yeah, and this motor, poor guy. That's basically the smallest motor on the entire printer. But the other ones had longer shafts, so I had to use this one for why, because it was the only motor that was like had the short shaft. So heaviest weight, smallest motor is maybe not the best combination. So yeah, I added like those heat sinks basically because I kind of put the amperage on this one quite high, so it got really hot. And the heat sinks kind of like etched that a bit. Let's also do a quick measurement here. So that's 6.5 millimeters. Let's quickly check if we can get this pulley off, maybe. We are more lucky here. I have my doubts, but yeah, okay. So it doesn't even want to give my bit back. Okay. Well, so here it is quite on. I have a big bag of pulleys for a reason, so. Oh, but that means we need our friend again. Hi there, Jordy. You didn't miss a lot. We just pulled off the bed, so the bed is off. And you see the white cable here, that's a USB cable for ADXL 345 that's under this aluminum plate. So basically we have like acceleration sensor for Y. Hi there, 3-print junkie. So, oh yeah, and we put new motors on A and B already. So putting a new motor on Y now, which is the last one. So we said 6.5 millimeters. But now that I said 6.5, was it really 6.5 or? No, it was 6.5. But now it's more like 7. So let's just try this again. Okay, 6.5 it is. Perfect. Yeah, and this one is bigger than the A and B motors. It's like 48 and the other ones are 40s, I think. I just want to have a little bit more oomph on Y. And these are, by the way, the same steppers that LDO has in their switchwire kit, which is more like accidental, but I was basically looking for like steppers that had like a good strength to speed ratio basically, and also like which one were like relatively cheaply available, and like each of them was like 12-ish euros, and I actually ordered them at Red Rig. So it was quite a good price, I think. Perfect. I always forget the belt is a mirror, like is really like, yeah, let's quickly do this again. Should be like the one thing you need to do is like put the belt over the pulley. Try again with belt. And then let's also right away try to tension the belt. So the one thing I noticed, like a while ago, I was doing like some resonance testing on the printer. And there's like the perfect sweet spot for the y-axis tension. Like if you put it too high, like the curves get quite bad. And if you have it too low, obviously the curves are also bad. So I think like, I mean, now that we just have the accelerometer on the y-axis, later we can just like really try like the best tension. This is quite high tension now. Oh, and we plugged in the motor, so we shouldn't move this like anymore. Because so basically, if you move the motors, you will induce power into the step driver. And if you like move this fast, basically like you can induce enough power into the stepper driver to fry the stepper driver. So you kind of don't want to do that. So one easy way to, so basically the goal is to have the tension on both sides the same, right? So what you can do, I have the end stop blocks here on top, and I know they are pretty much the same height. So if I move it up, this one now touches, and here there's like a millimeter of gap. So I know that I have to tension this side more. So if I pull this here, like this side moves up relative to this. So firstly, the belts are quite loose. So let's just tension them just like a little bit more. This one is quite tight already. Potentially why. Yes, there are apps for that and stuff, but I actually ordered like belt tension meter kit. So at some point in the future we have like a proper measurement. Okay, so now they're about the same. And also looks quite good. So if I push this one up here, I just tension until it touches on both sides. And now it's already even. So basically, like if it's even, you know the tension is equal on both sides. If you pull, like, let me just show this. So from the front, if I now move one belt, like the belt here on this side out, you see how this moves up. And it's not moving up like horizontally, it's like tilting. So it's basically like, if the belt tension is equal, the gantry is level. A solution for disconnecting the cable from the stepper. Yeah, yeah. So you can disconnect the stepper, but you also kind of want to use the stepper in a second. So that's why I connected them already. But yeah, so if you want to move it a lot, disconnect the stepper. Did you order the PF Makes one or another one? Oh, you mean the belt tensioner? Yes, the PF makes one. But the problem was like, so firstly, like, so I think we all saw the modpod video. That was kind of like the thing. Like I wanted to order it for quite some time. I didn't. Then I saw the modpod video. And I was like, okay, I should do that. And I obviously cannot order, or like I can order in the US at West 3D for the pre-assembled ones, but they were not in stock. And it's also like a bit of a hassle to order from the US. So I ordered at an Italian company. And yeah, should be here at some point in the future, but we have to assemble it ourselves. So I think it would just be like a fun thing to do on stream. And then I have like finally a nice belt tension meter. Okay. Last challenge. This plug needs to go through this hole. So let's see how we make this work. I think easiest is to remove the keybag clone. And easy is relative. And I should also replace those annoying screws. M5 by 20, and these were the only ones I had, or 25 I think. Okay, now we have a bit more space here. I think the easiest way to do this is basically just by lifting the panel up here. And kind of just pushing that down here. Okay, let's pull it from the underside. Kind of already pushing it in, or like putting the screw in, but I'm not tightening it yet. Because the cable is somewhere in between here. Okay. No, maybe not. Let's try to push this in properly. Because I also can't really install the keybag. It's a very... This cable has its own ideas on where it wants to go. No, it's in. I'm so annoyed that it's white. It's the only white cable on the entire machine. I really need to like order like a stash of USB-C cables. Let's go here. Okay. Have to put this over the idler on top again. Here we go. Cool. Technically we can install the bed again. And then we can do all the electronics underneath. Where did I put here? I have this very beautiful box. I think we need to replace the nuts, to be honest. Let's replace the nuts. I have fresh nuts. I don't like, they're like kind of worn out now. I think the screws are fine. Do we have the washers? Oh, we had them on the between the nuts. I was wondering whether we had them on the springs, but it was on the between the nuts. Let's see. Yeah, what I mentioned before, like one of the last things on this printer that really annoys me is the bed. I would love to have like a higher quality bed. But I don't think there's like a lot of like high quality beds that are lightweight. Because like for the bed stinger, of course, like it's kind of like it's important that it's like kind of lightweight. And that have like a higher quality than the Ender bed, and like exactly the size. Because like the problem is the Pusha Mark 3, Mark 4 beds, like they're most likely way better quality. But they are ever slightly too wide. They're like 1 centimeter wider, I think, or something, and that just pushes it over the edge where it just doesn't fit in between the vertical extrusions anymore. Let's see. I'm pretty sure I have M4 nuts. If not, I would be very sad. I think that makes me very sad. I have tons of M5 nuts. Okay, well then we have to reuse the nuts we have. Oh, wait. I'm just blind. M4 nut. Okay. I'm just trying to like put on the nuts before we flip the bed to the side. Just that like the screw doesn't come out. That's one. I do reuse the washers. Okay. 2. And we should use some thread locker again, because like I kind of don't want to deal with the bed constantly like changing. I mean, technically I have the BLTouch for like auto bed leveling, but yeah, so like I prefer to just set the bed once and then like be done with it. The only reason why I have springs here in the first place is that I want to be able to adjust it left, right, just from the height perspective. And if you have like fixed, like fixed spacers instead of the springs, Like you kind of have to live with the bed how it is. And this machine is not, I mean, it's not super square. It's square, but it's not the most square thing you can find on planet Earth. So, oh, this one still has a washer. The washer is attached here. That's convenient. That's 5 nut. So I kind of want to be able to like adjust the bed a bit left and right, or like up, down, left, right. But I don't want to have to adjust it all the time. So basically, once it's set, the bed leveling, or like the auto bed leveling, can do its magic. Okay, so I can just flip it over, and then basically it could have saved me putting this one on. Let's just add like a dab of Loctite, and the set time on the Loctite should be like long enough for us that we can like level the bed. Oh, that was way too much. First there was not anything coming out, and then I was like, I can already tell you next time we remove the bed, this screw will be quite well on. It would also be nice, like if you can just like, if there would be like a thread in the aluminium actually, because then you can just adjust it from the top. Only downside is then you have to constantly like take the build surface off to adjust it, so maybe not the best idea. Okay, let's try to be less messy. Okay, so I'm not tightening them yet. So basically just add the Loctite one by one, and then we can add the build plate and just like do like very quick paper level. And we first have turned on, obviously. So but yeah, we done. I mean, technically nothing is stopping us from turning it on now, right? Everything is kind of back into place. Yeah, I think we can just, oh, we still have to connect the electronics under deck. Let's quickly do that, but afterwards we can turn it on. Oh, and we have to connect this stuff here. One. Perfect. Let's quickly do the wiring. I think I just have to have this go around the spring here. Let's just do that again. Fish this cable out. And then again, like a little bit of design mistake here, so we have to push this in from the top. Would have been easier before connecting the bed, but we'll manage. We'll manage. Oh, one. Just have to make this pretty again. And then we can put it into our Vagos. The red one first, that's on top. See if we can fiddle this in. I think we fiddled it in. Okay, that's one. This one is much easier. It's also in, and the thermistor. Here we go. Like this is really really good because you can just like really detach the bed. And again, like if you want to ever switch the bed, it's very easy to wire up. You don't have to worry about the entire like, cable chain drama we just had. Now we're done. Just double check that it's all well in. Yep, okay. Then electronics time. There's not a lot of electronics. I just hope that the wire is long enough to reach. That would be like quite awkward if not. Wait. That fell over. Let's see. It is, I think, the perfect length. Yeah, see, it's kind of perfect. We have to like loop a little bit somewhere, but we'll be fine. I think it's best to just push it through here, and then we can just use the plug that's a little bit further out. Just close this up right away for like all the cables. Remember that they don't want to be in there. Which might already be the case. And just forget that you saw how messy it is in there. Okay, help me remember, the yellow cable faces down. Let's not flip this in the wrong direction, because otherwise we have one pi less on this board. Yeah, one thing I kind of forgot is that we kind of would need some mounting hardware here. And technically we can just push it on. It's just like not super secure. Well, ideally would have a spacer for that, but unfortunately there was none in the delivery of that thing. The other thing I kind of like screwed up is this is the cable I bought for this, and I was very optimistic with the length, and we could make it just work. If we are smart about, if we just first plug it in, maybe we can make it work. But yeah, or the longer cable. Nah, this is not gonna reach. So let's not try before we break something. So we'll just use the long cable, and then at some point I'll just swap that out for like the shorter cable. So we add a little bit more cable mess in here for now. Yeah. Lots of USB cables. Let's see. Okay, so technically we can quickly print some spacers. I'm just not sure how high they need to be, so let's just quickly measure. I assume like centimeter or something. Well, if I would see something, that would be tremendously helpful. We can also measure maybe in a spot where it's like a little bit more visible. Yeah, 10 millimeters. So we need 10 millimeter spacers. Let me actually quickly check if I randomly have some in my magic box here. I think like spacers and stuff I always just throw away, because I always say like I can just print them. Yeah, it's always cool. Let's just quickly print them. And what's the point of having a printer if you don't print stuff? Let's give me 1 second. I have to kind of size this window somewhat correctly. Here we go. New project. And then you can just add a cylinder here. So, I mean, right now my calipers would be really handy. So that would be like, let's say like 6 millimeters in diameter, or like from the outside. So let's turn on uniform scale. So in X it's 6, in Y it's 6, and in Z it's 10. And then we add non-primitive. Add negative part, cylinder. And this one has a size of 3 by No. Let's do like 20 in Z and 3 by 3. Then we say center. And then we say, oh, sorry, you don't see anything. We say center. Does it work? Just want to center this one. Center. Okay, perfect. So now they're like both centered. And these two combined we can clone. And now we have check, are they not floating? No, I think they're, oh, they are floating. So let's just quickly get rid of one again. And this one, let's just also scale that to 10. Yep. No, it's not centered anymore. I can do it. Is this quicker than Fusion? I don't know. I'm just not... This is still like 1 millimeter off the plate. Slice and see how this looks. Yeah, now we have like a... There's still first layer. Is that it or not? It wasn't floating all along. Okay, cool. Let's just print 2 of those. Arrange. And by the way, like everything in my on my machine is like slow again. So I have the suspicion that we will have a like crash at some point, like last stream, which will be fun. Okay, let's print those 3 bad boys. Yeah, this is kind of like, I think it's kind of cool that you can model stuff like that directly in the slicer, but it's a bit painful. Perfect. While this is printing, I mean, there's not too much to do. I mean, technically it would even be better if this white cable would go from top, because otherwise it's a bit too short. So we can rework this a bit. Trying to push the cable tie a bit down, otherwise we just open the cable tie. Or maybe we can even use the bottom one for this one. It's even nicer. Let's just quickly kill the cable tie here. The only thing I don't like with the bottom one, it kind of touches the buck converter here, so let's not. Oh. This goes in here then. Where did I put my cable ties? Just a new one. And then this can come from the top. Perfect. And we still have like 2 USB ports left, so we can add some more fun. Oh, but then basically for the back 2 screws, we just have then the spacers. And we just need like super long screws. So if I have that. The longest 2.5 screws I have are 10 millimeters. Well, that's something I should have checked before. So I don't have screws to mount that. Which is a bummer. Then I think we can skip the print, to be honest. I should have checked it before. I mean, it's not horrible, like it's completely like secured with the, like there's no movement here. That's fine. Like it's completely on the GPIO headers. I think that's fine. Yellow down. So we can power this up again. And then yeah, this is a bit loose, but again, like it's not a like moving part or something. It's not like a huge thing, so that should be fine. So I think we can just leave it like this. Which means technically we can just turn it on now. Let's quickly do that. Okay, are we ready? Maybe magic smoke, I hope not. No magic smoke. It's like I'm really concerned that like every time I turn on this printer, like the camera craps out. And not the camera technically, just like the HDMI level. So something is not nice here. Cool. There are like a couple of LEDs. It says like D1, D2. So I assume there's like some focus. D1, D2, D3, D4. So I assume it's like the USB ports. So D1, D2, 3, 4 are not connected. Guess that's a good sign. Let's see. This should come online in a second. Here we are. So everything works. Then we can close up the electronics. Just reconnect the LEDs. Yeah, and it's just fits. Like there's like not a centimeter of air or like a gap between like the LD strip housing and the GPIO headers. So this is like a really good hub actually. Like this is really cool. They do exist with like, I mean this is like for the 0 technically. It fits on the Pi 4, so all fine. They exist also in a larger form factor to like be like a proper Pi 4 head. But they're like super expensive for some reason. Like then it's a USB 3.0 hub, and for the Pi 5 you get it as a PCI Express thing, so it doesn't need like a external USB port. It just uses the PCI Express of the Pi 5. And the PCI Express ones are kind of cheap. They're like 10 to 50 euros, I think. But for the Pi 4, the USB heads, they're super expensive. They're like over 20 euros, and I was like not really willing to pay that, because the only thing that they offer on top is like that they are USB 3.0, but I don't need USB 3.0. I just need USB 2. It's like always the thing, like I can't tighten the screws. I have to first put in all the screws and then I can tighten. Otherwise there's like half a millimeter. It's half a millimeter off. Yeah, I'm not quite happy with the amount of USB cables flying around in here. But yeah, it's like one cable from the Pi to the hub now, which like I will replace with a very short one. So this is then at least like not this like big cable thing here. Then one cable that goes now to the tool head. Maybe we do CAN in the future, so this one would be replaced. Then the white cable going to the accelerometer on the y-axis. One cable from the board to the main board, from Pi to main board, and one cable from the Pi to the camera. So it's just like a lot of like USB devices, which is cool on the one hand, but USB cables are not super easy to route. You can't like put them to size, like or cut them to size. They're just like as they come, which is a bit of a bummer. Flip this over. And then let's just quickly see what happens if we do a stepper bus. So basically we just have to start over in a certain sense what we did last stream, like not quite, but a bit. Pull this to the front here. Over. So we do stepper bus, stepper equals stepper X. Yeah, so this stepper is moving. So it's just like buzzing back and forth, which results in like a slight movement, this 45-degree angle to Y. Y is working. Not sure if you can actually see that, but so that's Y. And then Z. So it's just like wiggling a little bit back and forth. So that's also fine. Then let's check the movement direction. That everything moves in the direction we want, because technically like still the steppers could like step in the wrong like in the wrong direction. So let's do our trick again, what we did last time. So we say set kinematic position x100 y, doesn't really matter. Y100 Z100, so it's just like things somewhere in the middle. To use the set kinematic position, just quickly showing that again. So basically what it does is like it homes the printer, and you just tell a clipper like, yeah, that's your position. You don't need to home, just like treat this as if you would be home. And to do that, you need to have this force move, enable force move true here. And then you have the set kinematic position command. It's really handy if you want to resume a print, for example, that got cancelled. And you want to like manually move the printhead and then just tell like, yeah. So you see like here's like X, Y, that's now 100. So what we can do is like in X, we can just move like 10 millimeters in positive direction, which did not go well. Last time we also noticed the acceleration is quite high by default, of course. So let's just do that slower. I'm not quite sure what it did here. Let's try that. Oh, I pressed Y. Yeah. I don't think the wiring is correct. That much I can tell. So something is not correct with the wires. So basically if I do X, you see it moves down, which is completely wrong. If I do Y, like it's also like not smooth movement. It's like, yeah, that's not good. So I'm pretty sure that the wiring is incorrect of the steppers. And it's the same for all three steppers. Yeah, so the wiring is incorrect. Hey, fun. That's my most favorite part. So we have to flip some wires. Let's do some research. Let's just quickly figure out how the Creality steppers are wired. Because the cables I have are from the Creality steppers. Let's just quickly check if we can find it online. So we look for Creality stepper motor wiring. See, I'm just looking for like Creality specific. Oh yeah, this is kind of what I'm looking for. Maybe not. Doesn't say. Okay, well, it's not really helpful. Then I guess like we can just use a multimeter to quickly check. Let's see. Would be smart if you would have done that before, but let's just quickly turn this off. So I think we just have the coils over across. Okay. So basically, we know that the two pins here are that. Like those two are not connected. The outermost and the innermost ones are. So these two are one loop. And these two are one loop. So it's really big. These two. And these two. Okay, so now we need to see, most likely for the LDO steppers, that's different. So I hope it would just be the same. Let's see. So it's a bit of a pain to access that. Yeah, I have to quickly take this out. It's impossible to get from this angle. Quickly losing the tension in the front. And then let's just quickly get the stepper out. We should have compared that before like putting steppers in. I think that's a good learning, like if you switch steppers, take the 5 seconds and just compare whether the connector is the same. Okay. I don't know whether it was naive of me to think that it would be the same. Let's see. So this one. Yeah. So basically for the creality steppers, right, it's across. So the outermost is with the center one on the other side. And here it's the other way around. It's not the center one on the other side, it's the center one on the same side. I know this exact. Well, working on all the motors. We swapped all the motors, but now I realized that the cables don't match. So we have the fun task now to like change the cables. I was naive enough to just think it would just be the same because it's the same plug. So I mean, what we could do is we can do it on this side. It's just like I really dislike this smaller JST connectors. I do have. Let me quickly check. If I have some replacements of the housings, let's just do it on this side. I think that's easier, then we don't have to like think hard which cables to swap. Yeah, exactly. I have a whole box of those. So we can destroy, like if we destroy the one that we have there, we have replacements. Yeah, surprising how much variation there is with stepper pinouts. Yeah, you know, you could just like decide on one pinout and just like do it the same. Like I don't know, it's so complicated. It's not a big deal, but still like, it's annoying. Yeah, like these like small pins are like, or like the small JSTs, like they're very easy to break when you like remove the pins. Which I was checking. But I have some new ones. Did you find datasheets for them? Yeah, the problem is more like the creality stepper don't have like a proper datasheet. The LDO steppers have datasheets. I was looking at them, the datasheet. But yeah, I just quickly used the multimeter and compared the, like basically which pins are connected. And then basically for the LDO stepper, the outermost and the center one on the same side are connected. And for the creality one, it's the outermost and the center one on the other side. So basically we just have to swap the two center pins and then it's the same. Only risk then is that the steppers run reverse, right? That we like basically like accidentally swap the coils. But this is something we should be able to fix in configuration, I think. Perfect. Okay. Let's just do this as a prototype. So before we do A and B, let's just check Y, because Y is kind of like the easiest. We don't have to deal with the Corex Z motion system. It's a really simple test. Just to see that what we're doing here makes sense. And if that is all good, we can proceed with A and B. Oh, and ballistic tech, what we also did is there's the white USB cable here. There's no ADXL sensor like under the bed here. So basically there's no ADXL on Y and one on X. From like Y, the one we just installed, and X from the toolhead board. So I don't have to use any external sensors anymore, which is like quite cool, I think. Okay, let's see. I think this. I'm still not sure whether I will ever get those pulleys off again. Like they're kind of like baked on there with like thread lock. Okay, let's see, this should come online at some point. Okay, I will just do the same stepper bus again on Y. It's stepper buses. So that's good. We didn't break it. Now the question is if I move the bed. So I set the kinematic position again. Now it's homed. So let's move the bed forward. No, so it should now move towards us. Oh wait. Sorry, that was set. It moves, now let me think. It moves in the wrong direction. Yeah, it moves exactly opposite like it should move. So things like we have two options to fix that, right? We can either invert the cables on the stepper. So basically all 4 plugs go basically in the opposite spot. So we swap the 2 from the left with the 2 on the right. That will, like the 2 coils on the stepper, we will just swap them and then like the movement direction changes. The other option is, that we just go into our config. Oh, that was my headset. I kind of need new batteries. 1 second. The other option is that we go to the printer config, look for our Y stepper, and then we set the direction pin. So the direction pin basically just like determines the direction. So we can just remove the exclamation mark, which is basically if it's like exclamation mark, reverse the direction basically. So now it should be the opposite direction. So we do the same kinematic position again. And now it should move towards us. It's really not helpful that the printer is like, like flipped around. Yeah, now it moves backwards towards us and forward. So this is fine. The only thing I'm not sure about, like I don't see why not. I think we can do the same for the A and B drives. I'm not 100% sure though, but I think it should be possible. Let's quickly tighten the magic screw in the front for tension. And later we can figure out the tension and everything. Let's just quickly check the Voron quick start guide. Because like if we now like wire everything, like we do the same switch for X and Y, what will happen is that we end up in this situation here, which you don't see because it's behind this thing. So basically X, this one here, X and Z is just swapped in basically. I'm pretty sure we can just invert the direction. We don't have to fix the cables. So let's just go ahead and first power down the cable. Power down the printer. Like I always try to shut it down properly because like otherwise you get problems with the SD card. You can corrupt the SD card basically if you just pull the plug. Just wait like 5 to 10 seconds and then you can kill the power. And now we can work on the cables. These are just a bit challenging because they're quite short. This one is longer than the other one. So Cassani Clipper, you still have to use the lowest value, right? I'm not quite sure what you mean, realistic tech. As always, I'm slow in reading chat. It's one of the pins. See if we also get that second pin back in. Oh, sorry, you just saw the back of my head. Between X and Y max acceleration. Oh, well, yeah, you have to use the lowest value. Yeah, because you can't set them independently. It's just one acceleration value for all the axes, including the extruder, which is kind of stupid, to be honest. So basically, like the acceleration of the extruder is also linked to the acceleration you set for X and Y. But yeah, for bed slingers, you of course need two different sensors, right? Because like the axes move independently. So I actually still have to configure that. Just do a quick wiggle test that like everything is like in a way that like it doesn't come out. There's one pin that I see is not quite in, I think. Yeah, this one. Try again. Wrong direction. Perfect. Okay, then all the motors should be fixed. Quick push the cable a little bit under deck here. Whew, okay, let's see. Then technically now the movement should be correct, but like the X and Z should be like, so that down will move up, but besides that, everything should be in order now. Okay, now I will reload again. So let's just do our like set kinematic position again. So if we do Z up, it most likely will, or yeah, Z up will move down. Oh no, it moves up. Oh, amazing, okay. And then X positive should move this direction. Easy, okay, just works. I like just works. That means technically everything movement system should be a-okay now. Then what we should do is make sure the bed is level. And for that I would need the build plate, which I kind of put over there. And then the other thing, like I kind of forgot this, right? Like the fan doesn't work, like the cooling fan in the back we discovered doesn't work. which is a bummer. So we have to fix that. But I think we can first do like all the movement stuff and then do the fan. Like I shouldn't do like a long print without that, but like for now it should be fine. Yeah, let me quickly grab the build plate and then we can do level and everything. 1 second. Okay, here we go. So let's just start with doing homing. Let's do XY first. I'm not quite sure why Y homes Y to the front. Funny. I mean, we redid the configuration, right? But like, since I had the printer, like it always homed Y to the back. So I'm a bit confused why it homes now Y to the front, but it works. So who am I to complain? So it's like just a configuration because we replaced the stepper configuration. But everything moves in the right direction. So, I mean, hey, let's home that. Cool. Then, let's do the following. Good old paper method. Just to get like everything somewhat aligned. And just because I'm a bit lazy, I'm just using like 2 papers. So let's just do it like 30, 30. No, it's wrong. Ha! It's the wrong direction. Okay, let's quickly change it. Now it thinks Y is at 30, but it's like at like 200. That's 100% not correct. So we shouldn't have inverted the direction pin. We shouldn't have inverted the direction pin of Y. Not quite sure. Okay, my brain must have short-circuited there. Like, we shouldn't have inverted the direction pin. Okay, let's try again. Home all. Yeah, now it homes to the back. So there's my confusion gone. Okay, let's try again. So we move to 30, 30, and then let's go to Z0. That's just because like the bed might be like super unlevel. Let's just go to 1. And then let's just go down in like 0.1. See, like it's already touching. So definitely this needs to go down. The only problem we now have, by now the thread locker, of course, is like kind of binding. So problem. Let's quickly observe that. So we most likely lost our time frame to do that. So I think what we can then just do, we just do it without the plate for now. I mean, it's just like to get like everything roughly level. So let's just, I don't see a problem with that. Like we can just level against the magnetic bed. Not like what you would do usually, but just to get like the bed roughly level. Benefit being like then we can just access the screw easily. And then like also let's level inward quite a bit. So let's do it at 50. 50? Not quite enough. Let's do 60. 60? Just so that like the screw is like accessible. Then let's go to Z2. And then let's just go down in teeny tiny. I just want to prevent like the drive in the bed because the bed is definitely like 100% not level. Okay, so now we are at 0.2. Yeah, that's just like I can just pull it out. There's quite a bit of tension, but it's okay. Let's just go a tiny bit down. This is very unorthodox, but move it up a bit. And go back to 0.2. Yeah, so now there's friction, but not too bad. Let's go up to 2, so that we like move over, like we don't scratch everything. Then we go to 225, 185, I guess. And then we just go down. Yeah, also here it's like well above what we expected. I actually want to go here. Let's see. Yeah, it's still too high. Again, like this is like just to get like it roughly level that the BLTouch can do its magic. Still too high. Now it's a bit too low. This direction. Lower. No, I'm going the right direction, wrong direction. That makes sense. Yeah, this is about the same. And then let's go. That is too low. Funny, like you need like really minimal. Something is funny with this one. I think now I have it. Teeny tiny. Oh, that was the wrong direction. I'm so bad with this. Yeah, like this. One left to go. And we said 60 on X. Move that down. I'm just doing that step by step. I'm not like ramming it in the pad like really hard. Oh, it says move out of range. Interesting. Most likely because of the Z offset. Oh, because it has a bad mesh applied. Yeah, and this this was a bad mesh before, so it was not good. Then how do we do that? Let's just because I know this needs to go up, so let's just quickly adjust it. Roughly, where do I put my? Oh, I left it here. This is funny to reach anyways. So we know this just needs to go up. Quite a bit. Now we are there. And this needs to be a bit looser because it's 0.3 instead of 0.2. But the thing is, like, now, because the bad mesh is applied, I'm not quite sure if like what we now set up is correct, because like it will have the bad mesh basically built in. So I think we need to disable. Yeah, we need to clear this bad mesh. Let's quickly do all 4 corners again just to check. Also, let's just quickly home. Because like basically we now did the corners, but like the bad mesh was applied. So the toolhead like didn't move straight, like it had its lost communication with that is not what I want to see. So basically it tells me like it lost connection with the toolhead board. Well, I mean, the board is on. There's most likely some USB trouble. Let's do a power cycle quickly. That's funny. Like, not funny, but interesting. I guess I mean, if you already now have problems with the USB communication, then that would be like a good reason to switch to Canvas. Let's wait for this to come online. Okay, so power cycle did work. Let's observe if this happens again. Let's quickly double check. Exactly load like the bad mesh again. So let's clear that. Does it home? Home all, yeah. Okay, no bad match. Let's quickly check if overhead was roughly correct. Let's actually just go to 65, to be honest. Just gives a little bit more space to work. And 0.2, let's go for it directly. Yeah, this is not quite stiff. I mean, it's expected that like the things change a bit. Like as you like go through, like if you change one corner, it will always affect with the other. Then Y was 160. This one was quite low, so I can move directly. This is really hard to grab there. Yeah, this corner is really low. Down. Halfway back. Somewhere in the middle of the two. That looks kind of good. Then let's go to 2mm set, and then let's do 160, 160. And 0.2. That's quite okay. So 2. And then Y is 65. 0.2. Yeah, this is not like really close, so this needs to be a bit down. Too much. Teeny tiny bit. Okay, cool. So now this is kind of like very roughly. It doesn't need to be precise. So let's just put this back to like 100. And let's put in our bed. It's definitely like higher up, like the entire bed's just like higher up than before. It doesn't really matter. Let's do a home, and then let's do like a bad mesh calibrate, and we just see like how bad it is. And now we can just hit calibrate with the default profile. Oops, move out of range. Why would that be? Is it because of the Z offset? Let's quickly go to printer config. What do we have here as a... This is a really high Z offset. Let's just put this to 3.8 for now. I know you shouldn't edit that manually, but or was there, wait, there could also be because there's position max. I'm not quite sure if we had something changed for position min. Let me quickly check the... I saved the config last time. One second, I'll quickly look for that. Printer config. One second, I'm almost back. Stepper Z. Oh, that's extreme. So we have position min used to be -6. So I'm not quite sure if this is... -6 is quite extreme, I think. That's just home. We also have to like still set the proper like amperage for the motor, for steppers and everything. Let's just calibrate that and see what happens. No, still. Oh, but it's like -20 in Y. But position min is 0. So where is it out of range? So we only have position max set here, and before, I mean, position min was set to 0. It shouldn't really matter, right? 0 kind of seems to be a default. But it's the only one that makes sense is Y, right? Because like it says move out of range. But I'm not quite sure why I would go to -20. Why would it do that? Uh-oh. That's not an MCU. Yep, okay. We won ourselves a canvas conversion, I would say. It already happened like twice now, just like slowly moving the printhead around. There will be horror with like printing. That's not good. It could be the cable. Could be the cable, of course, that like the cable isn't perfect, but still like, yeah, no matter what it is, like I was already toying with the thought of like just convert to canvas, although we just converted to USB, but if we now have like two of those outages already, not gonna be nice. Okay, let's try again the bad mesh calibrate. What I noticed, like the homing is much more nice, like it's more sensitive. Like we didn't adjust the sensor's homing values, but it seems like more gentle with like moving there. Okay, so we had a problem. X was a 10, which obviously works perfectly fine. Z was a 10, which works fine. So I think the problem is -20 on Y. Exactly, move out of range. 10 -20, 10. So if we say bad mesh calibrate profile is default. Oh, here's it goes to the same that we have here. 10 -20, 10. So I'm not quite sure what the problem here is. Let's quickly check the bad mesh. Mesh min is 10 -20. But it doesn't, okay. Let's just do 10 0. I'm pretty sure we didn't change that. We did not change that. Let's try again. Let's calibrate. It's a 5x5 mesh, so we'll take a second. Let's just hope it's like, if it's somewhat level, I'm totally fine. It's like really like the acceleration is at 3,500. Oh. Y skipped steps. It's screwed. Yeah, Y, just like when we moved now, Y skipped steps. So it's like the mesh is broken, but let's just quickly finish it. And also, like, let's check why. I mean, the acceleration is just really extreme. It's not extreme, it's like 3,500, but. Oi. I mean, it's something. This is 5 millimeters. This can't be correct. Like, it's not 5 millimeters higher. I mean, that's something you would see by eye, right? It's like 65. No, it's not possible. I don't think it's. This is not. Something didn't work. Okay, let's just quickly try it again. I just set the acceleration to like 1000. Let's just quickly first home again because the homing position was lost because Y lost steps. So yeah, it's most likely we just have to like adjust the. And there's another MCU. Okay. Oi. Not good. Let's check if firmware restart fixes that. It doesn't seem like it. Oh, it does. Okay. So we don't have to restart it again as well. Because like the first time it didn't, like firmware restart didn't fix it, right? I had to restart the machine. Okay, let's try again. So 1000. And let's just calibrate that. Oh, I didn't home. My bad. Well, that didn't take long. Ugh. I fear this. Now, like, it doesn't do it again. And even if I reload, like, it's not a like issue with Moonraker. It just doesn't do it. Okay. And let's quickly power cycle. Well, it basically means that I'll just order one of those. I'll see if I get it from a local supplier, so we have it next week. Yeah, one of those boards, basically. Man, that sucks. So basically, it's just like a CAN adapter. Need to tweak the buck to Pi now. It's drawing more power via the USB. I don't think the Pi is a problem. Quickly. We can check if the Pi has power drops, but because there's the board doesn't draw power from the Pi, right? The only thing it's added is like the ADXL, but I don't think that will draw so much power that the Pi craps out. But we can just check the power state of the Pi. Let's Google that already. Pi power supply check. There's this like command line tool. It will tell you whether it was undervolted. Exactly, this one. VC GAN CMD get throttled. And that will give you like a magic number. And then you know what's up. So let's just wait until this happens again. And then just check with the Pi what the Pi thinks is happening. Okay, let's try one more time. So this is 1000. We home. It's already happening again. You can tell because like the BLTouch doesn't deploy and then it craps out. Okay. Then let's check what the Pi is thinking of the entire situation. 1 second. So let me just quickly copy the command. So it's this command. (0x0). And that means under voltage. And it's also interesting, like it doesn't say under voltage has occurred, which would be 16, it's like under voltage. So at the moment it has under voltage. So Steve, you might be correct as always. Let's just quickly, just for the fun of it, like copy that, not as I misinterpret this. We see again CMD. I'm pretty sure 0x0, like it's just x0 means, yeah, I mean, cool, it's a hex converter, it's 0. So it's under voltage right now. Oh, no. 0x0 means nothing wrong. Nothing wrong. Okay. Then 0x5000 means throttle has occurred since last boot. And 5005 means currently under voltage. So our result means nothing wrong. Okay, then it's not that. Then it's not that. So Steve was a good hint. Most likely this means the USB cable is not up to scratch. It is connected though to the new USB hub. Let's try the following. We need to restart it anyways, right? Let's try the following. Let's just flip this over. Where's the plug? Here's the switch. Let's just flip this over. So this is the cable that caused the problem, the one that's doing the loop. Let's just swap some cables around and see if the hub makes the problem, because it could also be right that the USB hub that we installed is just not good. Or Clipper doesn't like USB hubs. I think USB hubs are fine for Clipper, but maybe also this specific one has a problem. At which point we can still make it work, because we have two USB devices that are not Clipper related. One being the camera, and one being that front USB port here. So if Clipper doesn't like this USB hub, we can just connect all the devices to the USB hub that are not part of Clipper. Man, it's the second time today I knock off the cover here. Okay, so that means just be a bit careful with this one. The white one is also Clipper, right? Like we didn't configure it yet, but it's the 8AXL. Let's just also get this out of here. Then I think this black one is the camera. Don't quote me on that. And this down here is definitely the USB. So let's just swap around. So basically, this one is the USB extension. Only place where we can put this is here. So let's just put this there. This is the toolhead board. So the toolhead board goes directly to the Pi. The white one is also like a MCU from Clipper. That's the accelerometer on Y. So let's just try to like convince the cable to go here. That leaves this plug here, which is the camera. Then we like loop the camera like crazy. I thought the camera cable was quite long, but it's not. Okay, then we need to, I think this one here, the extension needs to be routed a bit different. Oh, let's just get this out of this mess here. Quite easy, we can just slide this here. And put this here. So this USB cable now just goes to the front for this like USB port. And then the camera can go here. Okay, let's try this. So basically now all the Clipper devices are directly connected to the Pi. Let's plug this back in. As always, put all the screws roughly in position. Then we can put everything back together. Let's see if we now get like at least a bad mesh. Let's see. I don't think let's see. I just really hope it's the USB hub not being up to scratch. But then we can quickly ask Dr. Google. Clipper USB hub. USB hubs, both 2.0 and 3.0 work with Clipper. Under voltage notifications, we checked, that's not the case for us. Okay, let's see. So let's again like just reduce the acceleration for now. Then let's home that bad boy, or bad girl in this case, because it's named Charlotte. And let's do a calibrate. I mean, we are further now than we were before, so hey, maybe it's really just a USB hub. I feel like the motors are louder than the Creality ones. While this is like doing a thing, let me just quickly Google for the model number. 42 STH 40 16848C. Now we just get a data sheet on those. So this is the stepper. I did not buy it at 123, but I'm pretty sure they linked the data sheet here. Here we go. It's a data sheet. So this tells us a lot of things that we don't need to know. Oh yeah, and this is actually like the official motor that comes with the Voron switchwire kit. So, am I blind? Do I see the rate current? Rate current is 1.68 ampere, which let's just double check that with our board because we are using a SKR Mini E3 V1.2. I think it's a 2209 steppers, but TMC. Oops, TMC 22. Okay, doesn't say here. Data sheet. Finished, by the way. Let's quickly figure out what steppers we have. TMC? No? TMC 2209. I just want to know if I have 2209 or okay, 2209. TMC 2209 max amp. I think it's 2, but so basically the motors can do 1.68, the board can do 2. So I think if we go to like 1.2, technically it should be fine. We just have to check how hot they get later on. But that would kind of be like my aim then, that we have the steppers maybe at 1.2 ampere. I never run steppers high. So let's see what, also a little bit more research, what people say. Yeah, like my entire system is laggy as hell. But it's not too shabby. Like, yeah, it's not perfect. So basically the front is a bit higher than the back. Can we scale this a bit different? Yeah, so basically like it never goes down to 0. So it's roughly like one layer off, which is fine, I guess. Not perfect, not horrible. Okay, that's fine. Let's quickly check, because like these are the steppers from the LDO switchwire kit. Let's just quickly check the LDO switchwire config. Just see like what they use for as amperage for those steppers, and then just use the exact same shebang. Run current 0.5. So they're way low. Run current 0.5. So they're way low there. I don't know, like I kind of expect, because steppers have quite high, most likely you need way more cooling then. So let's just check in the printer config. So we are currently running 0.58 on all of them, 0.58. So kind of in line. So let's just keep that for now. So we are homing. We have a bad mesh calibrate. Let's do the following and let's configure the input shaper. So this is like kind of what I had from before, which was like an external like thingy. Don't want to say run at half the max. Steve, you might be correct with half the max. Which would be 0.8 still. Yeah. So let's just leave it at 0.58. Let's just first get everything to work and we can kind of like tweak that. But it means we have to flash Clipper again. And now I just realized we are kind of like royally screwed. We have to press the boot button on that device. Oh yeah. Yeah, I think we can press it. Oh god. They just put to the side. So basically we have to quickly put the, I thought they said 6070 max in a 0.2 sample config. Could both be true. I remembered that you have to like stay, I think like 30% below or something. That was what I had in memory. That's why like, if it's like 0.68, I would have thought like 1.2 or something would be fine. But yeah, let's figure it out later. Let me quickly, let's just flash Clipper. I just tried to get the picture of the board. Yeah, the boot button is on the side. Okay, yeah, we'll manage that. The only challenge is we have to press the boot button. Let's quickly check the manual. I mean, manuals are for losers, but let's check the manual. Interface, Clipper, compile Clipper firmware, page 8. Yeah, so we do that. Clipper bin. Hold the boot button and connect the board to Raspberry Pi CB1. Okay, so we have to hold the boot button and connect at the same time. That might be a bit of a pain. We should have flashed that before installing it. And then afterwards we see LS USB, RP2 boot. So let's first try the pain of connecting it. So I have this like butter tool and I can press the button. Just not quite sure if this is the button. It's a bit hard to press. Who would have thought? Okay, this tool does not work. Need to be careful, but let's try tweezers. This is not the most pressable button, to be honest. Okay, I can press it. Cool. I mean, now it changes. Pressing it. I think this was a success. Let's SSH and check LS USB. LS USB. RP2 boot. Yes. Yeah, I mean, a lot to learn, Steve. I just feel like I'm like when I do stuff on stream, I'm like so chaotic compared to like usually when I do stuff. I just like do things like, for example, installing it, right? Like I could have thought of just like, you know, flashing the firmware before installing it like in a place that's super hard to reach. Never mind. Okay. Let's just compile Clipper. Not much to do here, so we do cd Clipper. Let's just make clean, make menu config. This is on Linux process. We are now at a Raspberry 2040. Bootloader. What was the setting here? Bootloader, no bootloader, flash chip, W25Q080. Communication interface USB, so that's all pretty standard. And that's it. Escape, yes. Make flash, let's just say make first. I think you can also say make flash directly and we'll just build it, but and what was it then? Like serial equals, I think, right? Make flash underscore device. Make flash device. And now we should see ls /dev. No, we should see, yeah, 3 devices now connected. We need to figure out one of those 2, because basically like the toolhead board and this like little like accelerometer have both the RP2040 chip, like they show up both as this, like the number on the back is different. And then this one, the STM32, is our like main thing, the main board. I'm just copying one and just hope it's not the same that we already have. 50-50 chance. Let's be optimistic that we're lucky. Let's go to printer config. At some point I kind of need to like refactor those files. Like I feel like it's getting really crowded. So we add a new MCU. Let's just call it ADXL. Serial. And now the fun part. Yes, it's the wrong one. 50-50 chance. Let me just copy that over. So this one is a different one. /dev /serial /by-id /this. No, I wanted. So now we have 2 different Raspberry 2040s. Like one is like 2CA and 9A at the end. Then we already have the X here, this one. We need to see how this works. Firmware, but we are on the not 2.0 but 1.0. I'm not quite sure if they are different. Oops. And we also have to name them now, because we now have 2. So let's call one EBB and one Y-axis. Or BTT. Let's just call one BTT. And then let's also call this ADXL BTT. something like that. Oh yeah, BTT 80XL. Let's just call it how they called it. Okay. I'm just not sure if it's like, because I have version 1, which I know is a bit different, I think. But it only have one branch. Let's see, BTT XL V1. Yeah, there's this like 1.0 and 2.0 version, and I have the 1.0. So I'm just looking for the wrong thing. It's a different sensor. BTT. It was like half the price, and I'm cheap, so. Firmware. Here we go. Okay, they could. Let's just do what they do. So the board is now called this. So seemingly this is actually like a better sensor than the other one. I mean, from the datasheet, like that's a comparison of the two things, and we'll say like lower noise or something. No clue. Let's just still call this BTT. Then we just have to like the resonance tester. We need to quickly figure out how it works, because we now have two sensors, and like each is only testing one axis. So let's just check the configuration reference for resonance tester. Exactly, now we can set axle chip X, axle chip Y. And that's what we need to set. So basically we just give it like two different chips and say like, here, one is for X and one is for Y. And again, that's only like because we have like a bad slinger, because like the X and Y axes are moved independently. I'm not quite sure if this would be then underscore BTT, but I think we don't even have to name them, because it's like two different ones. It should be able to figure this out. The pro points, I guess it's kind of, doesn't really matter. Let's see what it does. Check. So it was able to connect to the new MCU. If we check here, we now have the MCU, the main one. We have the BTT list2DW, which is like the one we just installed, and the EPP, the Raspberry Pi, and all is handy dandy. And of course, like just last week, we updated everything, right? More updates. But yeah, I'm really like, yeah, let's quickly do that. Like usually once everything is running, I'm really not doing updates unless there's something I need fixed or like some feature I want. That really runs under the paradigm of like never touch a running system. I had like quite a bit of pain already with like Clipper updates, where like you run the update and then like stuff just breaks. Same goes like with the Linux updates for the host. I remember there was like this one thing where LSUSB or LSUSB or serial/USB by ID didn't work anymore suddenly, and like you had to like roll back a package update, which was, I mean, if you know how it works, quite quick. And I actually had the pleasure of doing that again at some point. But yeah, it's just like you just want to print something, and then like you are left fixing some weird stuff that you really didn't want to fix in the first place. So yeah, I'm really not a fan of updates when it comes to Clipper and like general packages. Cool. It worked. Then let's just home and then just see if the resonance tester works. I just need to remember the command for that. I always forget test resonances. Measuring resonances. So we can close this and this and this. Configure. Checking, measuring. Here we go. Test resonances. And I think we can just run it on both axes at the same time. Oh, you have to specify axis. Let's just do X first. And it's doing its wiggle dance. So that's good. Yeah, and then we can just check the other axis as well. Now we can just see what the things do. Like at the moment, not expecting too much. 56 hertz. I do like the camera, by the way. Like the new camera is really cool. Might need to tweak focus a tiny bit, but like it's way wider, so it's really nice to have a good overview. I didn't hear like a clear peak yet in noise. Didn't pay attention, but usually it's quite clear. Let's see, almost there. Super interesting. It's like on one level with like watching paint dry. That was X. I mean, let's do Y, and while Y is doing a thing, we can look at the X value. So, looking at the thing, so we run, let me just run this command and graph it out. And then quickly just show you the file. Yeah, now you really hear it. So there's clear resonance frequency. Wait, it wrote the file to a weird directory. 1 second. It was more complicated than I thought. And here you go. This is our resonance result. So we did have like a spike. Like I said, like 50, I did hear it, but like there's very clear spike. This actually looks quite good, I think. Like there's a little secondary spike here, but it's small. So it recommends the EI shaper, which is like relatively aggressive. 2,400, that's not a lot. I hope for more. And it's X. That's weird. Because usually I would expect Y to be like the worst result. And X is already quite bad. It was better before. It's done. Let me just quickly render the image. Yeah, we definitely have to check what's up there. And this is Y. So again, we have like a very clear spike. So that is good, or like the curve looks good. And we have MZV. So on Y, we have a recommended acceleration of 4,000. So there's clearly something wrong with X. So this is X, and this is Y. It could just mean that the belt tension isn't high enough. There could just be one thing, that we need higher belt tension on X. Because if you look at the... It's always a bit difficult to read because like exponential chart, but this is like 3. Both is 3. But here like we have this like hump. I don't know. A bit difficult. More is loose still from belt tighten. Didn't see you tighten them. Was away from that. They are tight. They are. I would also say like the belt tension is higher than it used to be honest. We can play around with that. We can play around with that and just tension the belt a bit more and just see what happens. The mounts are fine. The mounts are supposed to be loose. So basically how the mounts work on a switch wire is the belt tension pulls the mounts up and secures them. The mount itself is supposed to be loose. It's really like the belt pulling the mount up and securing it in place in a certain sense. So you have the 2 screws on the side that like kind of like allow the mount to go up and down. And then like these are not the normal mounts. These are already like kind of like a modified mount. So the normal ones only have the 2 screws on the side. And they are supposed to be loose, right? Because like you want the belt to be able to pull the motor up. And then you have this little hook here with this screw to tension it. And then like the modded mounts I have this screw in the back, which is already like additional. The original switch wire mounts don't have that. And this screw, all it does, it prevents the mount from like rotating around this axis. Because like with the normal mount, what I found, and seemingly a lot of people as well, is like that the belt kind of tends to pull up here, basically, and like this kind of like twists the motor a bit. So this is just like to prevent twisting. But yeah, like the motor mount itself is really like held in place by the belt. But it's also like quite common for all the printer designs. Like you always use the belt to like hold the motor in place in a certain sense. But let's just do the fun. They're quite tight already, but let's just see if we find something that's clearly wrong. I mean, one thing already is like we didn't secure this. And by we, I mean me. I make the mistakes. So let's just close this, but I don't think this was the problem. I mean, it's not ideal if this is flapping around, but the toolhead is also, I mean, as secure as it can be. I'm just checking if like the belt is in the eilers all the way correct. It also looks good. because like, the belt was loose, maybe it was, like, you know, jumped out of the track somewhere, but this all looks good. So the belt looks good. And we can also quickly do the fun and just run the thing again. Let me just run the x-axis again and see what happens. Maybe it's just a fluke. The tighten when you have the belt set. Yeah, tighten them. No, you don't tighten them when you have the belt set. You leave, like, the goal is really like for the belt to take care of that. You never tighten the motor mounts. Unless like I'm horribly wrong and I did it wrong on all my printers. For example, on the V0 you cannot even tighten them, right? In the V0 they are sitting on a slat basically. And the belt is like preventing the slat from like getting like the motor is on a slat basically. The belt runs around here. And you can pull out the motor without the belt, and the belt's just like pulling the motor forward. And as you tension, basically, you just force the slat further back. If you would tighten them, the belt might get loose over time, basically. Which the belt does anyway, so you have to tighten them over and over again. Let's see, so if it's still bad, I would just like increase the tension a bit on the belt and see if that improves things. And after that, the only thing left is the extruder, right? I mean, let's do, if this doesn't work well, let's tension the belts, try one more time afterwards, and then like fix the extruder and just print some small thing, right? Because I think we are ready to print. I'm not quite sure why like I lose time with like resonance testing. Okay, it's written. Let me quickly do that again, like the picture thing. It's still the same. So it wasn't a fluke. It was not a fluke. Just reload this. Yeah, you see like it actually got worse. So it's still like recommend shaper AI acceleration 2500. Let's just do the following then. One attempt. So let's just turn off the motors. Just moving that up. And I just tighten one side. Yeah, it's quite a bit tighter. Yeah, so basically this side is now lower. This side is lower. So I'm just like using my hands to like hold this up here. And then I just tighten the other side. Until it's even. Okay. Then let's home. And then let's just try again. Maybe that helped, maybe that didn't. We will know in a second. More like a minute, but. I mean, it could also be this table. This table is horrible. It's like really. It's also why like whenever I move something, like the camera wiggles. So it could also be just the table is horrible. Okay, while this is doing a thing, let me grab a roll of filament. I'm right back. Beautiful blue. $82 hertz, so more than halfway done. $105. Almost there. Super exciting. 130. Now it's done. First load filament and also like in parallel run that thing. Oh, let me actually do it. I still have 2 filament holders, which I guess is convenient sometimes. Let's see. Nope, still EI, still. Did it even change? 2221? No, this is not. 1 second, let me check. One, two, three. Because like, there should be like 3 files and there's only showing 2. So I'm a bit confused. Now it's 3. But still EI, still 2500. I'm not quite sure which file it bases it on. Bit weird. I assume it bases it on the latest file. Yeah, let's just run shaper calibrate quickly, then it will figure out all the things. We'll do both again. In the meantime, there's still one thing we kind of need to do. Yeah, we shouldn't touch the printer too much, but I'm not concerned with like hyper perfect results at the moment. We don't have anything at the moment to like guide the filament. So I think we'll just use one of those clips. Let's actually just put the clip on the back. So I'm just putting it on the back of Y. And maybe we do one on the side as well. And yes, don't touch your printer while calibrating. So I'm just guiding the filament through here. Just because I have so many clips, let's use another one. And later maybe we can just run a Bowden tube like through those 3 clips. I mean, I'm already happy that I can just run like shaper calibration without any cables, which is just pretty cool. On the V0, I also always have to connect this like stupid white serial flat band thin cable. See you, Dinga. Thanks for checking in. So I always have to connect that, and it's pretty annoying. And here it's just like, you just say shaper calibrate and it just does the thing. It's pretty cool. I like that. Okay, it did X. You don't even see it. It's moving. Trust me. We can also start slicing something, right? Like while we wait here. What shall we do? What shall we do? On why you really hear it vibrate. I'm sure you can hear it. We don't need those. I mean, we can just be boring. What's a Stanford bunny? It's quite a big bunny. Maybe we can make a small Stanford bunny. 20? Oh, wait, it's not. I disabled uniform scale. So let's just say 20. Teeny tiny Stanford bunny. Oh, 5 minutes is a bit too short. Let's make it a tiny bit bigger. Maybe double the size. Let's just 30. 10 minutes? Bit confused why it says it's so quick. 40. 60 minutes. Okay, let's do a 60 minutes Stanford bunny. Oh, we didn't calibrate the extruder yet. Oops. Let's quickly do that and then print the 60 minute Stanford bunny. So shaper calibration is done. It set everything up for us. So let's quickly see what that. MZV is recommended on Y. So for MZV, it used 4200 max acceleration. Let's see that we don't miss it. Oh, it tested both and then printed out the thing. Shaper X is EY. EY. It's most actually still 2500. 2600, yay. Okay, let's just also apply it in the slicer. For now. I'm just quickly applying it here everywhere. Okay, then extruder calibration. Let's do it really quick though. Firstly, let's just quickly check the Clockwork 2 extruder config. Stepper. I just trust that Google showed me that. Oh yeah, it's a Voron 2. Okay. Should be the same. Extrusion, rotation distance. So this is what we should have. And then gear ratio is 50 to 10. Printer config. Extruder, rotation distance. Gear ratio. see. Anything else? Micro steps and full steps. Let's just copy that. And then sensor type and stuff should be correct. I mean, this just defines like, oh, micro steps we now have twice. Not quite sure why it says 16. Let's go with the Voron value here. 32. Yeah, so that's basically just like that we have like the right distance, like roughly. The rotation distance we have to calibrate now anyways. So let's do the following. Let's just heat it to 220, that we have like no resistance basically. Let's also quickly home it. I think that's quite a good solution with just having it up there, like on those like clips. And it's just like freely. I'm not quite sure if I want to have a reverse button yet. Let's just move that up a notch. And then let's just quickly wait for the extruder to hit like 200. And I think we can just first extrude a bit just to see that it extrudes. If you like the prime. Not quite prime yet. You don't see the nozzle. That's the prime view. So let's just extrude a bit. It's just 50 millimeter. It's funny, you see it, like it spins around its axis, which is a bit weird. Not perfect. Not perfect to say the least. So I think there's quite a bit of friction here from the spool. If I just make sure that there's enough films available. You see that? Like how it's like, I mean, it's kind of like art. Not sure if this is good art or bad. Let me just like increase the tension a bit. I think I hear it like skipping on the filament a bit. You also see it like jiggling a bit. Ah, this is odd. I mean, I've never seen that. It's like the curly fries equivalent for filament. Let's do the following in a printer config. I don't think that's a problem, but let's just change the micro steps from 32 to 16, which it had originally. I mean, it looks tiny bit as if the nozzle would be blocked, to be honest, but like it's extruding fine, and then like it only towards the end of this like 50 millimeter like run, it starts doing that. Let's see what happens if I do 25. Yeah, it just starts like at the end of 25, it just starts with the curling. What happens if I do max extrusion tells me the firmware is like 50. I don't like that. Should be at least 120. Let's quickly see. So we need to change the max. Yeah, max extrude only distance. And this should be 120. Because later we want to do like the... I mean, it should be 100, but 120 is fine. Let's see. Again, let's make sure the temperature stays at 220. So now I'm just like, for the fun, let's just try what happens for like extruding 10 centimeters. This is so funny. I'm really like, I mean, it looks a bit like if the filament gets twisted. Right? Like, okay, so it's definitely something with the extruder is not right. Maybe it's the speed. We're extruding quite quick at 10 millimeters per second. Let's just do the same. Let's just do our extruder calibration thingy. So let's just see when we calibrate it, how it behaves with like slower speeds. So basically what we do as always to calibrate our extruder, it's kind of like this like holy thing. So we mark 120 millimeters, which is a bit difficult actually. $120 and my finger. And then we extrude 100 millimeters at 1 millimeter per second. This is not 1 millimeter per second. Oh, it did not set the 1 millimeter. Okay, let's try again. It didn't apply the 1 millimeter. Let's try it again. It's the upper end of that mark. Now we're extruding 1 millimeter per second. Very slowly. I think it's just like 10 millimeters per second was just too fast. That's where like the spinny thingy came in. We'll take about a minute, roughly. Longer, right? 1 millimeter per second. Not sure if 1 millimeter per second is too slow. I think it always was 1 millimeter per second. So we'll take 100 seconds. Just make sure there's enough filament available to be pulled in. I do have this quite long wide. Oh, yeah, we also. No, we didn't. I'm really winging that. So it's just like a bit of Voron tube, which we can put there in a second. Is it done? Yeah, it's done. So I put the filament in a bit of an angle. That's spot on. I'm not even kidding, this is spot on. Wow. I've never had that. Like, in my life. This is the first time we try this. It was the upper end of this mark. You don't see the mark, but... There's the mark, and the upper end of the mark was at the 120. That's spot on. Okay, wow, this is... I don't know what I did to do this, but that's good. That means two things. That means basically one thing we can print. Not sure why I said two. Let's just quickly do the following thing. So I have this Voron tube, which is very wide in the diameter. So you see it's like very, very loose. That's just to guide the filament, basically. We added these clips on the back. So I'm just putting this around, not here on the side. Just have to like somehow secured it somewhere. But yeah, like the idea is just to have this like loosely attached here on the side. Just that like the filament is easier to pull for the extruder. Well, we have a model, we have our bunny ready. I think we are like high time to print. Here's our bunny. It says 18 minutes. So like the slower acceleration made like 2 minutes difference. I'm a bit sad. Let's just hit it. Let's just hit it. Off we go. There's also something like oh. No. I mean, no, it was fine the entire time, right? It was fine the entire time. Okay, we know we need to reboot, we need to power cycle. It was fine the entire time. Okay, so it was not the USB app, so maybe it was just a fluke that was like working on the entire time. Okay. Well, that means this will not be the last stream of this build. This can be a good thing or a bad thing, depending on if you like the series or not. I will order like a U2C CAN adapter. And next stream we will convert this thing to CAN. Because it's also not the MCU under the bed. Like this never like once had the problem. It's only the EBB toolhead board. My guess is it's a cable. It's usually like whenever I had such issues, it was always the cable. It was always the cable. If it stays in the blue, oh, you don't see it. If it stays here, that basically means it cannot connect to the board. So if you quickly go to printer config, they have now this like devices tab here. We have only 2 USB devices. This is the STM and this is the RP2040 with the 2 CA. So this is the yeah. So the EBB MCU did not come online. So let's do one more power cycle and see if it recovers. Man, it's like, it's so close. Come on. It's like everything is ready. We can print. And that feels unfair. Let's just power cycle that again. Let's see, so once it comes back, we have one last attempt. And if it doesn't connect, then I will just call today and end the stream and immediately buy adapter. Yeah, this is not good. Now my question is the board alive? Because now it doesn't come on anymore at all. Yeah, I mean, there's a LEDs on, so I assume it's fine. Well, we could try just to troubleshoot it now, because like now it's not coming on at all. Give me, oh no. I have a USB-C cable. Let's do the following. This is really short though. Let me grab a longer USB cable, and with this longer USB cable, we will basically connect this USB here to the front USB I have, and then we can just see if the USB is the problem. So let's just open this up. There's also a screw here we have to undo. Oh, this was really... Huh. This was not well connected. I feel like this thing pulled it up. Okay, then it's just the connection here, which also is not confidence inspiring at all. So basically just pulled out the plug. Let's just wrap this again. Like this piece should prevent this from happening. But seemingly it doesn't. Maybe this printed part is not quite compatible with the USB plug, but yeah. Decision made, CAN bus it is. Like, I don't feel like I can pull out that USB plug from here, but let's just try again. Let's try again. Oh, this is preheating. Let's quickly add the cable tie back. So I feel like this cable tie is relatively important, but it could also be this cable tie that pulled it out. See? Luckily this bed heats quite quickly. I think it will do a probe run actually. I did not install adaptive bed meshing here. So if we do like another stream, like let's also like install adaptive bed meshing on this machine. Two more degrees. Oh, so it's like, well, we're waiting for 2 degrees. Let's close this here. Just on time. No errors yet. It also set the 3500 acceleration again, so I'll quickly set this down to 2500. The camera is pretty good. It's pretty... Yeah, now it skipped steps again. So this needs to be like 3500 is not okay for now. We need to tune the motors a bit more. Yeah, now it doesn't, the buttons don't do anything again. I feel like that's maybe a bug. I just restarted via the top menu. Yeah, so seemingly Clipper doesn't accept the firmware restart command sometimes. So we said it just sets this by default. We need to change the config. Let's just do this manually for now. And then the slicer should apply 2500. I like that the kind of like setup moves are quite speedy. By the way, we also didn't adjust the I just hope the Z probe offset is fine. We didn't change it, so it's still the 4184 that we had before. Yeah, it's much better with the 2000 acceleration. So I think we just really have to like increase the motor currents quite a bit. Oh, it's also, I'm pretty sure I'm running those motors in stealth job. Do I do that? No, 999. That should be off. Cautiously optimistic that we will have like somewhat a successful print. Yeah, we definitely need adaptive meshing. Okay, heating the hot end. So basically always heat the bed to like target temperature. Then I do the meshing. Like technically you should maybe wait at the target temperature of the bed for like a bit, because like the bed will still like warp itself a bit. And then I do like the probing, and then I continue heating the hot end from 150 to like target temperature. It's basically like just the 150 is just as hot as you can go without it starting to like ooze and stuff. So that's why I want to wait with like the final temperature. Exciting. We're working on this like for like 4 weeks now, right? I think so. It took us quite a while to figure out the cables. We'll start any second. Oh no. Move exceeds maximum extrusion. Oh no. Where are you, extruder? Max extrude only distance. Let's quick see. Just move exceeds maximum extrusion. There's one config field we just have to set. Max extrude cross section. We just set it to 1, I think. Man, now we have to do it again. Oh, that sucks. Print. That's what you get when like, because I just replaced the config with the standard config. It's like all those like little tiny things that you like at one point in your life set, all gone now. So we don't need anymore. Don't need that anymore. I could have also quickly exchanged the print start to not. Oh, now it's at 3,500 acceleration again. 8,500, it's even better. Why is it? Oh, that's the wrong printer. I'm looking at the wrong printer. The V0 is allowed at 8,500. Let's see, we need to pay attention if it skips steps, we have to start again. But cautiously optimistic that it can do it. Already at 4 hours now. That LDO started super late. Now we skip steps. Let me also quickly check this max acceleration 2000 if we don't have to constantly think of that. Yeah, no, the firmware restart button doesn't work again. So we can restart Clipper and then we'll complain that the MCU is not in the correct state. Firmware restart. Come on, you can do it, you can do it, you can do it. Print. Yeah, like the I'm not quite sure if it's a good sign, but like it's way more subtle, like the docking or like the contact when homing. I mean, run current is really low. The motors are also like barely warm, so I mean we're not driving them really hard at the moment, but let's just see. Okay, we can do it. I'm kind of toying with the thought of converting this to like ERCF. Would be kind of pointless, but I think it's a really cool thing to build. It kind of like intrigues me to build a ERCF. And I think this would be like a good printer for it. Now that like, I mean, it's still like, will run the same issues I had with like the feeding of the filament isn't like quite reliable. But like if I combine it with the cutter on the side, potentially this solves a lot of issues. Okay, at least we're not getting the bad level done. Here we go. Let's wait for the hot end. We can do it. If we don't get anything printed, that would be really sad. Yeah, almost there. No, I want to see some extrusion, please. I also feel like we need to do like a little bit of pit tune, because quite like it overshoots the target quite a bit. And see like how it's like if it keeps the temperature stable like once it's on the target. Yes, 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 it's doing it. And I mean, the Z offset looks printable. I'm not saying that's perfect or anything, but it's printing. Definitely not perfect. Yeah, we're getting there, we're getting there. I'm not so sure if this model would have needed like 5 bottom shell layers, but I think it looks good. Cool. Very nice. I mean, this needs to be a bit quicker in the end. Like I'm not quite sold on like the 2500 max acceleration. But I mean, on Y it was kind of okay. We just have the issue on Y we skipped steps already at 3000 millimeters per second squared. But I think it's mostly like just a motor calibration issue, because I really like those motors are not really warm. And the filament is wet. I hear it like popping. Like it's like the matte PLA. When I bought it, I didn't know it, but like matte PLA is not really PLA. Like it has quite different properties. It's matte. It prints roughly PLA temperatures, but it's really brittle. Like it's like a really poor layer adhesion, and it absorbs moisture like crazy. Like not like nylon crazy, but for sure patchy crazy. Not really like the things you print with it look really cool, but it's not really like nice to print. And definitely like not for mechanical parts at all. Like PLA is not never for mechanical parts, but even in the scope of PLA, It's not for mechanical parts. See. Cool. Yeah. I mean, there's not much to do while it's printing. Oh. This is the Allen key I was looking for the entire time. So, hey. Cleaning up already paid off. So let's see. Yeah, like, I mean, it's printing. We still need to do like a shitload of tuning. But yeah, everything is working. The motors are working. The accelerometer is working. Bullet board is semi-working. I think what the problem is, like the USB plug is relatively short. And they have like this like printed part around the plug that's supposed to hold the plug down. But like the printed part kind of bottoms out for me. So I think what I need is just to shorten the part of it to ensure that this printed part like pulls down the USB-C plug. And then maybe it's okay. But I also still have still mind what Rushmere mentioned last time. That there were like some cases where the USB connection killed either the EBB or the Pi from like coming undone a little bit. So I'm still kind of on the fence just because of like you spooked me a bit with that. So I'm kind of like on the fence just based on that to switch to the pure CAN connection. Let's see. So potentially I would just do like another stream where we switch to CAN, but I just have to like order the parts for that. I mean, it's just the one board, but I definitely need to order like USB cables because I'm absolutely like out of USB-C cables. I always had like a million USB-C cables from like all different things. I'm completely out of USB-C cables. So I need to order that, so I'm not quite sure if we would do that next week. But what is also still on my to-do list, and that would be amazing if we can do it at some point, is finishing up the PC case. Which, I mean, I now have all the parts. We still have to build the I/O panel for that. It's actually something that annoys me a bit because I have all this like loose dangly cables flying around. So potentially we just do that next week, that we work on the PC case, finish it up. There's also like some soldering work. The stupid cables broke again from the power button, like for the LEDs. So I'll just replace it with the JST connector. So there's also a bit of soldering work there, and yeah, so maybe we do that next week. Just because it annoys me and I want to do it for a long time. And then the week after we could finish up this bad boy here. And I also posted about the printer I'm working. LED toolhead. Steve, you're right. It should be on, it's not on. Well, okay. We added to the to-do list to check. The LEDs should be on at the moment. There should be LEDs. And according to like what Clipper says, it's on. But it's not. So odd. But the fan works. Not sure you can't hear it, but the fan works. So switching off the fan did wonders. Yeah, so I'm also working on the printer I designed myself. I really have not a lot of time at the moment to work on that. But I posted about the X-axis, which I now have at least an idea how it works. And I'm kind of ready to print that as a prototype, and we could like build that Z-axis in the stream. The only thing I kind of want to like, I have two problems still. One is I have no clue where to put the power plug because it kind of doesn't fit anywhere, which is a bit awkward. And the other things I want to include a deck panel. And I kind of want to know how the deck panel works before I print all the parts, because I at least want to have the hope of using those parts, not having to reprint them because I added the holders for a deck panel later on. So yeah, I feel like I have too many projects going on, but I think it's fun to like just like switch it up a bit as well sometimes. So PC case needs to be done. This needs to be finished up, including investigating where our LVs are. And then the third one would be obviously working on my own printer. I still don't have a name for the printer design. I was thinking of calling it chopsticks. That's the only thing I really came up with, because I use all the different rods. Maybe it's the chopsticks printer, but let's see about that. Let me have like a... As always, like, you have a much better view with the camera, to be honest. To be honest, it's like one of those cases. It's not horrible, but it's not good. It's printing. The overhangs are horrible. I really don't think the cooling fan I have now is good. Like, it's noticeably less airflow than the one I had before. You can really see, like, on this side where like the overhang here is quite steep on the front. With some pointing device. Like right here, it's not really good. The rest looks okay. And it's very rough surface, so always a bit hard to tell, but like it looks acceptable for like a first print after having a new extruder and new motors, and kind of okay. I had much worse. That's much worse first prints. It's more like, I remember the first print of the V0 like was like what's the problem there? It was like super blobby, and like the retraction was horribly wrong. Because for some reason, like the default V0 configuration had like a Bowden extruder configured in I think I used Prusa slicer back then. And it was like not good. Let's see, so it's 5 minutes left. I think we also have to like move up a bit. But yeah, like the one thing that really annoyed me about this printer, like before we did like all the upgrades now, was like the bone extruder, and that's gone. So I never have to like hassle with like stringing again and like tuning retraction settings to oblivion. If that's gone, like this was all worth it. This is a very nice printer. Like I really like this printer. It's just like it was such a hassle with the extruder. Let's see. So I mean, it's so uneconomical to like spend more money on a printer, but like it's just like tinkering on it. So let me think about the canvas. If you want to go to canvas or not. I'm like 60-44 moving to canvas. Although it's kind of like annoying that we just like finished up the USB. So canvas is still list. As I mentioned, like I would love to replace the bed, but there's just nothing on the market that really like seems doable. And then like the other thing is like I really want to have an eddy probe on there. We have the setup, we have the spring steel bed and everything, so we can use the eddy sensor for like replacing the BLTouch. And I'm kind of like eyeing with the BTT eddy. but they don't have a canvas version yet. And if I would do that eddy sensor, I definitely would want to have canvas on the eddy sensor and canvas on the toolhead board. Because then I only have to run one cable, because right now it's 2 cables. And I'm really not in the mood to run 3 cables to toolhead. So at that point, it must be CAN. And I read in some like random Reddit thread that Big Tree Tech will also supply like an adapter cable for connecting the eddy and the BTT via one canvas cable. Because at the moment, like, there's no way of on the EBB to like connect the second CAN device directly. There's like the CAN out in the front of the tool, but it's kind of like awkward because it's like in the wrong part of the self burner, because it's part to take off. So let's see. I'm a bit concerned why the LDs aren't working. Again, like the LDs used to work, right? We saw them working once. I very vividly remembered it. Let's just see. So two lights. Sepper, bam. Two light. EBB GPIO 16. I'm not quite sure if this is correct. EBB 2209 config. Let's quickly check. I'm kind of like going in loops here. Here, sample config. Here they call it PD3. So potentially it's just a completely wrong pin. But they all called like GPIO something, so I think I'm just looking at the wrong config. SB canvas? I'm not quite sure if this is... BTT209 USB config. I'm just really confused why for me, I can't remember where we got this like sample config from. But most likely from some manual. Because this looks completely different. Quickly check the manual. Oh, you're missing the ears. Oh, we didn't update the slicer configuration. It's still like a bones setting with retraction and stuff. Oops. Yeah. Okay. So the LEs are for next time to figure out. This is our sample print. So it looks okay. Firstly, we used 0.28 millimeters layer height, which I did not check. So that explains the very coarse layer height here. Like the very coarse layer height. The other thing is like this is still like on Bowden settings, so that explains all the nice stringing here. So there are things to be improved, but it's a bunny, and I mean we can kind of clean this up. So I'd call that a win. Like the bunny itself looks quite okay. Like the overhangs are a bit poop, but hey, not everyone has a bunny like that, so I call it a win. Yeah, first layer is let's not talk about first layer, please. But it's also like still like it's worse. It's not as bad as it looks. There's some black filament here, so there's like actually like some strains of black filament, I think, which I'm not quite sure where this would come from because we like purged like a lot. But yeah, the overhang is quite bad. Yeah, and like everything that has to do with retraction and like layer change is like ooh. And the overhang at the ears is really bad. Nah. So I feel like I most likely will have to order another cooling fan. And there's also like some extrusion issues for sure. Like see here, like there's this one line that's just missing extrusion. So there are things to be tuned. So we'll definitely like come back to this printer and do some more tuning. Cool. Okay. Yeah. So toolhead light we check next time. And tuning and stuff. So more work left to do. But yeah, for today I would call today. And thanks for tuning in, everyone. Quite a few watched actually. And yeah, see you next week. Enjoy your weekend. And yeah, have a good one. Bye.